Scientific notation. The last of a little mini lesson unit of 3 lessons on multiplication property of exponents, division property of exponents, and now scientific notation. Scientific notation utilizes both division and multiplication property of exponents, and that is why it is here. So I hope you remember how to do that. We will get into that later. But for now, let's just talk about scientific notation. Now, if you recall, before we had something like 3 to the 20th power. And you recall maybe that you saw this long, disgusting decimal with times 10 to the 9th power, and you thought, what the heck is this? That doesn't look like a number. Well, this is scientific notation. It turns out that most numbers in existence are way larger or way smaller than you ever really can even imagine. Like if I asked you the question, how many grains of sand can fit on the ocean floor or filling up the entire ocean? Or how many water bottles can you stack on top of each other to fit from the bottom of the earth to the moon and back? Or backwards, how many miles are in an atom? They're going to be either numbers or decimals that are so unbelievably large or small that they can't be written out in this nice space of a calculator or on a sheet of paper. But we still need to talk about those numbers. We may not have names for them, but we still need to know not only how to write them, but how to calculate with them. Scientific notation, named because scientists do this all the time, that's why I brought up some examples with atoms, is when you take a number and then you have this times 10 to the some power. Why times 10? Because if I have a number like 3 and then I multiply it by 10, I get 30. And if I multiply it times 10 to the second, I get 300. And 10 to the third, notice 3,000, 30,000, 300,000, all the way on and on and on. Each time I'm just adding a 0. Otherwise known as I'm moving the decimal point one spot to the right. Now if I go backwards, so go back to my 30, well remember any number to the 0 power is, that's right, 1. And so if I go backwards, I keep getting a smaller and smaller decimal. Well, now you'll notice that I get one additional 0 or one decimal space to the left instead of to the right. That is why this times 10 is used all the time with scientific notation. It's about adjusting that decimal point either right for positive exponents or left for negative exponents. Okay, there's a brief explanation, and let's dive into our assignment now. Number 1 says, write the number using standard notation, -8 times 10 to the 8th. So what this means is that we have -8, and then we need to go 8 digits to the right, or we need to move our decimal point 8 to the right. Well, we don't have any more digits, so I'm just going to move this 1, 2, 3, 4, 5, 6, 7, 8 spots to the right, and all this invisible space that's here, that needs to get filled in with zeros. So 1, 2, 3, 4, 5, 6, 7, 8. And notice what it says. Do not use commas. Do not include commas in your answer. So instead, type in what you have for your first number, in this case -8, and then however many zeros you're going to type in depends on what exponent you have up here. So I've got an 8, so I type 1, 2, 3, 4, 5, 6, 7, 8. And that's it. If you have 12, you type 12 zeros. If you have a 30, you type 30 zeros. I don't think your number's going to be that big, but you just never know. Okay. Also, I'll show you if you were to type this out in your decimals calculator. Remember that the to the power of button is down here. You could also replace the 2 with whatever number you want, but sure enough, it tells you negative 800 million. Yeah, I like this little spacing it does between each of the 3 zeros. It's very nice for reading. Okay, we only have 7 problems today, but we're going to go through a lot of different kinds of scientific notation. The first one is we're going backwards. So now we start with this, it's called standard form number, and we have to go backwards to write it in scientific notation. Well, we know that we have -6 in front, so if yours is negative, write a negative sign in front. If it's not, don't. And then we need to write our times 10. So we have a choice here. We could either click this little arrow to the right of our division sign, and there are 2 different signs here for multiplication. So we could write like times 10 to the, and then count. Well, my decimal is right after my first digit every time. So 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. Or, check it out, your calculator, not the Desmos calculator, but your graphing calculator and lots of other calculators, can shorten this whole times 10 thing to just, it's a little weird, but the letter E. So you can put -6E9, and that will also work as -6 times 10 to the 9th power. And I will show you that here. So if this confused you, like, what? I was spacing out. I went to the bathroom. Where's this E come from? This is literally the same thing as writing out -6 times 10 to the 9th. It gets rid of the times, the 10, and instead of having to put that 9 in the exponent, you just type it right after the E. I'm going to show you both because I get that's confusing. It looks a little weird, but it works. All right, number 3. So now, again, if it's negative in front, put a negative. We have 2 digits that aren't zeros for the first time. Here's what we do. We still put the decimal point after the first digit. We didn't have to worry about that before because we didn't have anything else after our first digit other than our times 10 or our E. But because we do now, put -9.2, or if you have like 86, put -8.6. But type both digits and a decimal point after the first one. And then we'll have a choice. I promised you I'd show you both ways, so I'll continue to do that. So you can do times with the dot or the X to the, and then I want to count everything after the 9, including the 2. So if I put this decimal point after the 9 and then count digits, including the 2, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, that can be shortened to 9.2 E10, either way. So 9.2 times 10 to the 10th, or 9.2, or -9.2 E10. Okay, 3 down, 4 to go. Now we have a negative exponent for the first time. Well, it starts the same way. We're going to type this whole first number, and if it's negative, still type a negative like I have. If it's not, don't. And then times 10 to the -6 means instead of after my 1, I'm going to go in front and type 6 zeros in front of the 1. 1, 2, 3, 4, 5, 6. Now notice where the decimal point goes. Don't put it where my cursor is blinking right now. Don't put it afterwards. Your decimal goes after the first 0. And you can check that by pressing the right arrow by the number of times you have your exponent. So I've got a 6 up there, so I'm going to hit right arrow 6 times and hope that it gets back to the right of the 1. Here we go. 1, 2, 3, 4, 5, 6. Okay, that perfectly does, so I know that I will have the correct answer. And there it is. So this negative in front corresponds to the negative in front. This other negative in the exponent corresponds to going left instead of right. Pause if you need more time to stare at that one. See the pattern. But we're going to move on. We're going backwards again. They give us standard notation. We want to write scientific notation. So we've got 4.1. Notice mine is not negative, so I don't type the negative. And then I need to type my times 10 or E. I'll show you both ways again. So times 10 to the, and then because I have a decimal, remember, just like above, let me zoom out real quick. Okay, there you go. So remember, anytime you have a decimal, you have to have a negative exponent. Well, I've got a decimal, so I need a negative exponent down here. And then I'm going to count how many zeros, including the one in front of the decimal point. So I have 1, 2, 3, 4, 5, 6, 7 zeros. Otherwise, I could also stick the decimal point in front of the 4 and count backwards. 1, 2, 3, 4, 5, 6, 7. I'd have to go 7 spots to the left in order to reach my decimal point from the 4. So I've got 4.1 times 10 to the negative 7. You could also put 4.1 e negative 7, like that. Totally your choice. All right, so that's writing and converting numbers in scientific notation from both standard form to scientific and scientific to standard form. Now we need to figure out how to calculate. So normally this would be very difficult. I'd have to write out 3 times 10 to the 4, so that's going to be 3 with 4 zeros. Then I'd write out 2 with 3 zeros. I'd do the computation, and then I'd have to go backwards to scientific notation. That's a lot of work. I don't want to do that. Instead, let's follow this pattern. Take your first 2 numbers. So I've got 3 and 2. Basically, your 2 numbers that do not have your times 10 to the some exponent. And you're going to multiply them together. So 3 times 2. And I'll even write that out here to be really explicit. 3 times 2, 6. So I type 6. Okay? Now remember what I told you at the beginning of this video. It's good that we're doing this after multiplication and division of exponents because that's what we're going to need on this assignment. Well, it's come time now to remember what to do when I have 10 to the 4th times 10 to the 3rd. That becomes 10 to the what? 10 to the 4th and 10 to the 3. That makes 10 to the 4 times 3? No, remember, we just have to add our exponents. So you multiply your first numbers together and you add your exponents. Oh, and I screwed up because I wrote the 7 still as. All right, hold on. Reminder what this is. This is either, so I'm going to multiply my first numbers again. This is either 8e4 or I mixed them up when I wrote it. I'm just going to do 3 examples for you to give you a lot of practice with this. Or, hey, 4 times 2 again. It's the same one. 8 times 10. I'll use the dot this time. To the 2 plus 5 is 7. There you go. Either way works. Okay, and then number 7. So for 6, I multiplied my first 2 numbers together, and I added my exponents. Now we're going to do the opposite. We're going to divide our first 2 numbers by each other. So 6 divided by 2 is 3. And then instead of adding our exponents, we are going to subtract them. 6 minus 2 is 4. And that's it. And again, we could either use the e or we could use the times 10, but don't do what I did when I made my one mistake and combine them. Don't combine the times 10s and the e's. All of you out there, I hope this was not too large of a task for these too large of numbers to write down manually. This has been Scientific Notation. Much love to you all. Hope this finds you well. Until next time, this has been Class Away from Class. Dylan is signing out.